Okay, that seems to be working. All right. Feel like I put this here. So what is the point of what I'm doing today? So it was suggested to me recently that it would not actually be too hard to write an Ethereum virtual machine in Lean. This is something that people have discussed a little bit before on the Lean forum, like Lean Zulip. I go here. It's incredible that that's not the first Google result ever. Zulip. Lean. This is so weird. Lean Zulip, and it doesn't provide a link. I guess maybe the issue is that this is not something that is like on the public internet or something. Anyway, if you like search for Ethereum, you see that there was like one person several months ago who asked this question of whether there was like any sort of any like work implementing Ethereum in Lean. Taking forever to load, but whatever. So it seems like something that might be possible. So I think that like my main advice to this person when they came was to just like use some like pre-existing Ethereum client. Here, let me see if I can reduce some of my some of the like random things in my visual field right now. Okay. Not obvious to me that I will be able to like see anything that's going on. I go to my own like channel here. Basically like to mute myself here, but that seems fine. Okay, hopefully like I'm not destroying my internet by doing this. Yeah, there's like the thing is that there's some people who have proposed implementing Ethereum in Lean. And it's not necessarily too hard. So the question is, where can we find an implementation like a Geth, right? This is the most famous one. Go Ethereum. They have a nice website. I guess I want their GitHub. So consensus is not what I want. What I'm interested in primarily is seeing if I can like write an EVM, right? Ethereum virtual machine, EVM. Ethereum virtual machine spec opcodes. So we have like a bunch of opcodes. This is a handy table. Okay, so presumably I would have to like do this, but my goal is that I can find some way. So I've created this project here to like put all of this. And my vague goal is to be able to just find the correct part of this this GitHub repository, like literally copy and paste it in, and then like see if GitHub Copilot will start, like if I just like get it going a little bit, see if GitHub Copilot will start like translating things for me, which I'm mildly optimistic it will be able to do. But the key thing that I want to find is like the EVM, virtual machine. Virtual machine. does this ... mean that there's like way too many? Yeah, whatever. Okay, I'm not even like signed into GitHub is maybe part of the problem. Is it in ETH? Gas estimator? No. Client core. VM. EVM.go. Wonderful. Let's like, what is the contents of this file? Precompile. Okay, well, precompiles are something a little complicated. Yeah, my understanding of what a precompile is yeah, okay, this is like coming back into my memory and like telling me that this is going to make things hard. But a precompile, as I recall, is like if you have some like special cryptography that you don't want to take as much gas as it would otherwise take, you create, like, the Ethereum community creates a precompile for it. But the point is that this will make EVM much more complicated than it otherwise would be, because now it's going to be like some sort of external thing. Precompile. Maybe the point is that from the point of view of the EVM, it just looks like normal EVM codes. It's just that when something happens, clients know that it can be precompiled and run it in a separate way. Common.address. What I almost want to do is like clone this and then like start clicking around. Yeah, maybe that's the right decision. We're gonna go Ethereum. Go Ethereum. Code. Copy to clipboard. Okay, new terminal. What is my git clone? Go Ethereum. So this will presumably clone that. Wow, it takes a long time to even clone. How much code is there even present in Go Ethereum? I guess there's like all the consensus code and lots of stuff here. So like something was being referenced in common. I wonder if like the definition of account is in here or something. Sorry, like just clicking back. Yeah, okay, so that's done. So now why don't we write code? Open this in VS Code. It's gonna be called go-ethereum. Okay, so here we have Go Ethereum. And in fact, we'll put it on this side. We should also like increase the size of the font. Should be something that we do over here as well. Otherwise, it won't be possible to read later. Here we can increase the size of the font over here as well. Wonderful. Okay, so I'm in core VM evm.go. Core VM evm.go. And the question is, do I possess this? Do I possess Go for VS Code? Hello, yes. I would like the official Go extension for Visual Studio Code. Do I have this all installed already? FG Go. Yes, I do have Go extension installed. Wonderful. So I think I can just immediately, yeah, everything looks syntax highlighted. And the main thing that I want to know is if I go to the definition of common.address, will it take me there? See, part of the problem though is that is it going to, okay, cool. It took me to the address. Yes, an address is a series of bytes. 20 byte address length. Untyped int equals 20. Cool. So we have all of this. My next question is, does GitHub Copilot like know? So I think it's the case that GitHub Copilot will like sense things in your project and like use them. New file. There's also just the possibility that like GitHub Copilot has read Ethereum clients often enough that it just like memorized certain things. Text file. Okay, what would I really want to do here? Let's create a folder called leth, calling it leth by analogy with reth and geth. Let's make a file called vm, like evm.lean. I don't really know, it's like capital letters. I can like import MathLab, right? Import MathLab, capital M MathLab. We'll be happy to handle this. Like, example. If A is a list of nats A by simp. Is this something that is capable? Waiting for lean server to start. Starting lean language client. Okay, so like some things have to happen before this will work. But eventually at some point it will work. Here, I feel like this is even not big enough. I would like something a bit larger in terms of font. Yes. Lean configuration changed. It says it's starting the client. Can I just like restart lean? Client is already being started. Okay, fine. So hopefully that's working fine. I think the main thing that I want, right, is, yeah, Copilot is functioning. The main thing I want is like, can I type in block context? Like, so this is, right, this is like just a, you know, it's like a, what do you call it? It's like a normal type with a whole bunch of different fields in it. It's like a conjunctive type or whatever. Not exactly sure what the like type theoretic terminology is. Let's close the Explorer. The thing, yeah, okay, so I was going to suggest that. What I want is an inductive. Connection to server is arrowing. Shutting down server, okay. Okay, well that's not a good thing. Inductive thing called block context. Block context. Well, it's not immediately working. What happens if I type in can transfer? That is obviously not working. Okay, this is not what I want. What I want is like a struct, right? Not an inductive, but a struct. I'm just being dumb. It's like struct, inductive, they're all the same. Structor block context. This is an interesting suggestion. Offset indent. Offset, offset. Like this is sort of weird how crazy it's gone. The next thing to type is where. That's not, so like can transfer. If I start typing in can transfer, and that's not of the type that I want. Can transfer func. Signature of a transfer guard function. Type block context. What is a block context? Provides the EVM auxiliary information. See, this is like it's like some external thing. Transaction context. Type EVM struct. EVM is the Ethereum virtual machine base object and provides the necessary tools to run a contract on the given state with the provided context. It should be noted that any error generated through any calls should be considered a revert state and consume all gas operation. No checks on specific errors should ever be performed. The interpreter makes sure that any errors generated are to be considered faulty code. The EVM should never be reused and is not thread safe. Okay. EVM start. Context. Block context. So we have this block context. TX context. I don't even know, like, TX context. But it doesn't provide, like, it doesn't provide a name. Is this some weird, like, Go thing where it's like a subtype or like object-oriented programming? Who knows? We have a depth, chain config. Yeah, information about the current chain, that's fine. Chain rules. Is that really a part of the EVM, like the chain configuration? I feel like chain config is something that like contains information about, like, you know, the block, the like origin block, or the chain ID. Yes, identifies the current chain. Various forks. That's probably changes Byzantine block. Net split block. Shanghai, Cancun, Prague, Verkle. Verkle switch time. Okay, interesting. Chain config. Lots of different functions. Yeah. Call code. So is this the state update function? Like I'm more used to seeing, like, if you go to like a beginner explanation, like EVM beginner explanation, you'll see like some diagram of like a state update function, which I think is often like some obscure Greek letter. Beginner's Guide to the EVM. No actual information is here. Okay, whatever. I just want to like start translating. Right, so okay, now that I actually have downloaded this, I can delete it. So I'm deleting that. Contract ref. Package.go. Like, where is this defined? Core EVM. Core VM contract.go. Address. This is in common. Common types.go. Yes. Yeah, it certainly seems like it all could be like translated somehow. Comparison operation. Yes, so it's like an order instance of like linear orderable on addresses. That's fine. They're all like strings of bytes, right? Type address is like a 20 byte. Is it the case that like if I go for the lean for docs, like byte, is there a byte type? Byte array. Data array uint8. But I want a specifically 20 length 20 byte array. Can I make that type? Byte array. Can I make that type? See, like it would usually be defined like a vector, byte vector. Not optimistic. Vector of bytes. No. Yeah, see, you can get the size, which is probably just the like underlying byte array net vs.size. Data is an array. Yeah. The thing is, you don't want to be like running around proving everything is 20 bytes long when you're making this, so it's not necessarily what you want to do. Like, I feel like I should maybe like try harder with the vector type. There's definitely like a vector type. Vector A and this type of list of length n with elements of type A. This is not a type that's like very heavily defined to be like easily computed with. It's like under the covers it's like a function type. No, I guess I'm wrong. It's a list type. But it's like a list type and not an array type. Which means that it's like not designed to be, you know, like unary operations and all of that. So that's sort of unfortunate. Yeah, sort of funny that all these, like, it's definitely much more common in other languages to have that. I don't know why Lean, I guess, is just like not compatible. Okay, well, whatever. Lean is, I'm not gonna do that then. So like, what should I start translating? I feel like I want to like start translating the core logic, but I'm not sure where that is. Like, where does it reference the like bytecode and like the meanings of the bytecodes? I feel like if I can identify that, if I can find the place where like essentially the table, right? There's like the magic table. Where did I do with that? EVM opcodes table. If I can find the place where this exists, stacking, it's not going to be like referenced here. Sign extend. Can I search for it? Sign extend. No results found. You would think that, that's sort of weird. You would think that at least at one point in like the entire code base, there would be like a reference to the name of the opcode, even as like a comment. Of course it has that, but oh, it's because I'm dumb and I'm searching in the wrong folder. Sign extend. Sign extend is the name of some opcode. Op sign extend. Instructions test. Okay, so here's a test file. Instructions.go. Yes, we have all of these things. Op mod, op jump table. Yes, yes. I should perhaps think of like, ask the question, is there like another language that would be easier to translate? For example, like Rust is a little bit closer to Lean in terms of like translatability, I feel. Whatever happened to like it was like this project at some point. Yes. Rust to Lean. This project. I'm supposed to be able to verify Rust code in Lean with this. Currently has backends for Lean. Yes. Project structure. There was some like comment at the end about how it's like we don't like support for loops or something. Plan to target safe Rust, no support for unsafe Rust, though we plan to design a mechanism to allow NES in combination with tools targeting unsafe Rust. You have the following limitations. No nested loops. No functions, pointers, closures, traits. When was this last updated? 11 hours ago. That's encouraging. Maybe, okay. First of all, there is something called reth, right? reth. This is like a reth client. Paradigm XYZ, reth, Rust CRM. Yes, cool. Modular, contributor-friendly, and blazingly fast implementation. So they always call it blazingly fast. That's sort of funny. Ethereum protocol in Rust. Reth made in Rust. Wonderful. So my key question is, can we literally, can we do something on the order of literally just pipe this entire repository into this repository? Installation and build. You need to install OCaml. That is sounding like a nightmare. I don't want to install OCaml. No. Why is it in OCaml? That makes me sad. We rely on Dune, which is an OCaml thing. Okay. OPAM install. Oh gosh. Oh, okay, now I have to reconsider my choices. We use OCaml. Installation and build. Is this something that claims that it can actually do this compilation to the Lean backend? Backend for Lean, right? Okay, let me just read carefully. Verification toolchain for Rust programs relies on a translation from Rust's MIR internal language to a pure Lambda calculus. Okay. That sort of mildly suggests to me that it's not going to be what I want is something that will give me something that looks like idiomatic Lean code, not some random Lambda calculus garbage. Intended to be used in combination with Charon. I mean, that's maybe what I'm asking for just doesn't exist, but whatever. Compiles Rust programs for intermediate versions of LLBC. Backends for these languages. OCaml. Need to install OCaml together with some packages. Follow some instructions and install OCaml. Yes. Some dependencies. Requires the Charon ML library defined in the Charon project. Clone Charon. Go to compiler. Create a symbolic link. See, it's such garbage. It's I don't even know what a symbolic link is. Why can't you just make your code easier to run? If you want to test the symbolic link, okay. Well, this is making me less and less optimistic. You run make, generate a documentation, usage. The Aeneas binary is in bin. You can run bin Aeneas backend. LLBC file generated by Charon. Aeneas provides a lot of flags and documentation. Yeah, okay. Additional steps for Lean backend. Oh, additional steps for Lean backend. Okay. Files generated by the Lean backend import the base package from Aeneas. To use those files in Lean, create a new Lean package using Lake New. Overwrite the Lean toolchain. The one inside backend.lean. What the? Use those files in Lean. New Lean package. Support the base package from Aeneas. Import the base package from Aeneas. Okay, I see what it's saying. It's saying that, there's some package, right? It's gonna make reference to certain things that Aeneas has to then provide. Yes, that makes sense. Overwrite the Lean toolchain, the one inside backends.lean. Add base. Okay, but okay, so now what it's telling me is that I'm gonna have to use a super old Lean toolchain if I even want it to work. One inside backends.lean. Add base as a dependency in the Lake file. Require base from path to Aeneas repo, backends Lean. Targeted subset, and it's a targeted subset. No nested loops. Okay. No function pointers, closers, traits. Actively working on this. Limited type parametricity. Yeah, So like lots of like random issues. Okay, so maybe go back to the like Copilot plan. There was like another option was like maybe using Python. There's like Python EVM, right? Python is such an easy language. Surely that will be EVM, Python implementation of the EVM. And like above and beyond, it's just okay. So this from the Ethereum Validator, the PyEVM is just the Ethereum virtual machine and none of like the other stuff that I don't want to deal with right now. So this is maybe a good way of approaching it. This is where the content is. VM. Okay, just incidentally, is this the exact same? Like if I look in Reth here, source. I feel like when I was looking at Geth, I clicked the wrong thing. I don't want this. I was looking inside core. I had a whole bunch of things. Okay, it's a whole bunch of different ones. That's sort of fine though. Okay, so here's the PyEVM. Let's delete some other VM is here. Recompiles, yes, that's something else. State, computation. This is maybe optimistic. State. Base state consists of a computation class, a computation API. What the heck? Transaction context class, account DB class, transaction executor class. Like, shouldn't it be like a list of accounts and the details of them? I guess the point is that like there's an account database which contains all this. Get account DB class thing. Yeah, this is sort of what I'm beginning to worry about. It's like all of these implementations are going to like reference some database to like store all the accounts, and I don't want to like do that in Lean, because what I want is like an actual sort of semantics of what the EVM is doing. Account DB state root. Yeah, okay, so this is just totally unhelpful. Like account database API. Okay, like can I like clone this repository as well? Code, copy. Full screen this. ETH VM like opcode.py. It's like slightly nice that we have a type for opcodes. Mnemonic. Gas cost as opcode. Mnemonic gas cost opcode API. Every class has like an additional class which has the letters A, P, and I appended onto the end of it. What is this? Opcode abstract base class. Obviously, this is some Python thing from 5 years ago. Execute. the logic of the opcode. Is this like really going to be easier than this? The thing is, this is like the actual like code base, and there's going to be like lots of like random things that are sort of extraneous. All unassigned slots with op undefined. New constant, right? Because they updated, I think. That's sort of funny. This is just some like huge dictionary. Jump table. It's a map. It's a map from 256 to operations. Yeah, okay. Min stack, max stack. So these are like the number of stack values that they access. Execution context is defined here as well. If I like try and I want like, yeah, contract caller address. The result of the caller which initialized this contract. Caller is a contract reference. Contract ref interface. It's an interface. Ah, okay. Well, that's actually slightly different. It's an interface which provides an address. Why is this different from this? Self as a contract ref. Yeah. Why is this a common.address and this is like a interface to a common.address? That just seems like redundant code. No? Result of jump dest analysis. Okay, I'm beginning to believe that jump dest analysis is beginning to feel like this might be like specialized performance code. Like if I go to contract, if I find contract here, chain context, execution context, surely there's like a contract. Code values, yes, these are the names. Mnemonics, they're all strings. Opcode values. See, like I could write, I could definitely get the AI to like just copy and translate this into Lean very quickly. Memory, interrupt header, chain context, chain ID. I don't know what's in here. I don't know what's in here. Tests, scripts, consensus. Consensus shouldn't be relevant here. Why is there like a why is there a folder called consensus in a repository called EVM? I don't really get that. These are databases. Is there any reference to like contracts in here? Compiles, yes, bunch of precompiles. Tools. Good word. Just like give it to me. Contracts created. that say benchmark? Weird. Compile contracts. Go to definition. Iterable pathline.path. For path and contract paths. Compile contract path. Contract path of type pathline path. What? Okay, this is now we're in like Python. I don't really get that. Compile contracts. Contracts root. Just some like namespace of contracts. Contracts equals rc20.sol. dos contract.sol. Contracts root. These are like Solidity contracts. So this is a Solidity file extension, which again should like have nothing to deal with what I'm doing here because I just want to deal with the bytecode. So I don't know what's going on. A bunch of reference to like forks. Spurious Dragon. They had some like really interesting fork names early on. Cancun, cool. Computation, execution context. Okay, so like, let's just like see what actually do we have here, right? We have address from ETH typing, import these things. I wish I could like see ETH typing, unable to import ETH typing. Okay, is that some like other repository? ETH typing. Okay, so there's like now a whole other thing I would have to import. Common type annotations. ETH typing. EVM.py. Yeah, a bunch of like. Okay, maybe not like technically necessary for that. Sorry, can I like change the order of these? Yeah. Address, block number. Doesn't seem like too terribly critical. Execution context. But what I would like is to be able to yes, initialized all these values. Coinbase, timestamp, block number. Okay, we can execution context. Let's just like start translating things. Waiting for lean server to start. Okay, what is the deal with the lean server? Why are you not starting? Starting lean language client. Can I? Maybe I need the fetch the cannot run project action while restarting the server. Okay. Why does it never like work the first time when I'm like make a new directory? Okay, it's starting a lean language client, but obviously it is not succeeding in starting a lean language client because it's been doing that for the past like hour. So how do I reboot this? Like stop, don't do that anymore. Like if I click on this again, starting lean language client, I don't want you to do that anymore. Please stop. Like does it even understand what's going on here? Hello world. It's not working at all. If I if I open some other, like, let me open MATLAB. Hello, are you able to start the lean language client? Folder contains a dev container. Yeah, but so this one is successfully started the client because I can see it like with the little thing here. So what we're going to do is close this window. But I can't close this window because like I'm streaming it. That's so weird. Why does it change the way that my window looks when I'm live stream it? I just want to close the window, please. Yes, thank you. Close the window. And now I want to reopen the window. Here, screen it. The info view seems to have started, so it seems like it's successful. Can I like put it on full screen, enter full screen? Can I combine these two windows so that I can see them both at once? That seems much better. No info found. But it does like know what a type is. Okay, and it's running. Okay, cool. Things are now running. Why did I want everything to be running? Because I wanted to go back over here and start like translating things. So I want a structure called execution context. Execution context. Okay, so like here's like the thing. What I really want to do now is just add the like whole project. Can I do that? Let me take a look. If I just, yeah, I have this, and I would just like to copy and paste PyEVM into this project. There you go. That should be fine. PyEVM, that is in that project. Okay, I don't need you anymore because I'm about to reopen you elsewhere. So I'm gonna close this window. I'm gonna go back over here. PyEVM contains everything I need. If I go to example to ETH, to VM, to execution context, I have this file open now. Cool. And the question is, can I now, like with this tab open, can I now like structure execution context where? It's not giving me what I want. Coinbase address. I think I want lowercase. Coinbase. Type address. Is that right? No, it should be timestamp next. Timestamp. Is it a uint64? Is it int? What is it in the like in the Go version? I'm looking for execution context. I should just like copy and paste the Go code in as well. Execution context. Hello, where is execution context defined? Retrieve the execution context. Yes, I would like to retrieve a context. Context. Go to definition for the context. 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 I don't think this is right. Like, I feel like I was seeing something like this. Precompile block context. This isn't this exactly the same though. Block context versus Coinbase timestamp block number difficulty. Coinbase block number. There's no time block number difficulty. Is this supposed to be like the analogous type here? Block context provides the EVM with auxiliary information, which sounds like what execution context would do. Is this one supposed to be like the reference implementation? Implementation of the Ethereum protocol in Python. Low-level primitives for original proof of work chain as well as emerging proof of stake. Eventually, de facto aims to eventually become the de facto Python implementation of Ethereum. Wide array. Be a reference implementation. Okay. Yes. The beauty of having like multiple clients. In theory, it should not be too hard to do this. If I just understood, if there was just like a good explanation, a high-level explanation of like what the important parts of the EVM are. Put this here. State, depth, chain config, chain rules. I don't like know how that maps onto anything. I can like define these types presumably. And it's sort of like pointless, but I could in theory define these functions. I mean, this is something that you would never define in an actual like these property functions. Yeah, I mean, they've done some like weird Python stuff where it's all starts with a like underscore and then they have a different one. The lean version changed. Why did the lean version change? Shouldn't have changed though. Is there something about like the opcodes? I just want to be able to like write down all the opcodes. Opcode consists of a mnemonic and a gas cost. As opcode. Shouldn't it also consist of like the byte that like corresponds to that opcode? Did I like delete? They like, so all the opcodes additionally have a number associated with them. Is the opcode values, right? Stop, constant, literal, go to definition, right? It's, yeah, that's where it's defined. So they all have, yeah, where is the part that maps the names onto the, state.py looks optimistic. Base state. Stack. It's a stack of EVM operations. Operations that push to the stack have the data in some natural form. Right, it's been described to me that the Ethereum virtual machine is stack based. I guess that means it's like a call stack. I don't know what a non-stack based VM looks like. Performance note. Operations that push to the stack have data in some natural form, integer or bytes. Whatever operation is pulling from the stack also has its preferred representation to work with. Typically, these two representations line up. We have a notable amount of conversion time by storing heterogeneous data on the stack and converting only when necessary. Push int. If len values is greater than 1023, full stack. So a stack can only be 1024. You can push int, push bytes, pop one int. These sound, I mean, like, these seem like operations, right? These seem like operations that are probably down here somewhere. Like push 1, push 2. State. Yeah, this is all one big base state class. Does something inherit from this class? Is there like a state that inherits from base state? Is it somewhere down here? Base state. Coinbase. How does Coinbase work? Self.execution context.coinbase. So it has an execution context. Where is the execution context? Right, it comes with an atomic database API and an execution context and a state root. DB execution context. So I have to write execution context first. Address. Where is address defined? Go to definition. No definition from. Wonderful. Yeah, it's defined in ETH typing, of course. Hash 32, bunch of ints. Cached adorable number. I don't even know where this is. Okay. Mnemonics. So we have one Python file with all the mnemonics in it, and we have another Python file where all those same literals are defined in terms of the values. Spoof. Stack. This was all written like 7 years ago, right? Oh. Base state. Can be translated. With information about a transaction. All fields can change between transactions. I mean, maybe what is worth looking into is like whether I can do the Rust like translation without like any like special tool. In ref source, yes, commands. I don't know where to find anything in this, of course. Create stocks, etc. Examples. You have tests. I don't think that's what I want. I think what I want is here. Utils. No, not that. It's always impressive how like the core code isn't just some buried in five subdirectories deep. Like don't know how to navigate this. Tools with a Z, unable to import. ETH ABC. This it's able to like import fine. Let me take a look here. Database for accounts. State root as root. Alright, so this is like in theory a type class that could be implemented. Like the main thing, I was never able to like find that one like thing that I remembered. Ethereum state update function. How is the state of Ethereum blockchain updated? Where is that diagram? Fuck. Ledger to state machine. Yeah, like here. This is like the one equation that I wanted to be able to write down. I wanted to like be able to like have a type for states, have a type for transactions, have a function that takes in a state and transaction and returns a new state. Behaves as a mathematical function would. Given an input, it produces a deterministic output. I think they're sort of simplifying that there because there's all this yada yada about context as well. It therefore is quite helpful to more formally describe it as a state transition function. Old state S, new state transactions, state. The context of the theorem, a state is an enormous data structure called a bona fide patrician Merkle tree. It keeps all accounts linked by hashes, reducible to single root hash stored on the blockchain. But I don't want to think about that, right? I just want to think about it as like a map of like a list of accounts. I don't really care how the accounts are stored. Transactions are cryptographically assigned instructions from accounts. EVM instructions. EVM executes as a stack machine. Okay, like let's read the Wikipedia on stack machine. Stack machine is a virtual machine in which the primary interaction is moving short-lived temporary values to and from a push-down stack. To and from a push-down stack. How do you do loops in like Ethereum? Aren't you able to like execute for loops? Load store. This is sort of interesting. I'm beginning to worry that my entire like conceptualization of how the EVM worked is just wrong. A stack machine, like if I go to the list again of right, I can like jump. Mark a valid destination for jumps. Yes. Like alter the program counter. Right, it's like a von Neumann architecture or whatever it's called. You can like move the program counter. So what does it have to do with the stack? Is the point that there's like an instruction counter and a stack and memory? Is that the point? Maybe this diagram will help. EVM executes a stack machine, depth of 1024 items. Each item is a 256-bit word. Yes, for the cryptography. During execution, maintains a transient memory. Does not persist. Contracts, however, do contain Merkle-Patricia storage tree. Yeah, sure. Smart contract bytecode executes as a number of EVM opcodes, which perform standard stack operations like XOR and add, sub, etc. The EVM also implements a number of blockchain-specific stack transit operations such as address, balance, block hash, etc. Right, the gas available. Okay, no, this is just account storage. Yes, okay, so the stack with more gas can operate with the account storage, and it also has like a memory apparently. I don't really understand what the diagram is attempting to communicate. EVM implementations. REVM. Maybe this is what I want. This is an implementation of the EVM in Rust. Fast and simple to use. Does not have the sort of downside of being not strictly typed language. It's in Rust, and maybe this is like better focused. It's not like an entire ETH client. Okay, but can I find where the important stuff is? Crates, I think, just refers to crates. What does crates refer to in Rust? Like, I thought it was like modules. It's the word for modules. EVM.md. What is inside? EVM is a proprietary structure that implements the EVM virtual machine. Stack-based virtual machine. What is inside? It is consisting of two main parts. Context and handler. Consists of. All of these are MD files. REVM. All of these are MD files. Is everything in this directory an MD file? I thought this was a Rust. I thought this was a Rust code base. Am I just insane? Okay. Maybe this is where the binaries are? Nope, this is just more markdown files. Is there anything in this that is not a markdown file? Am I totally crazy? Wait. Crates. Maybe this is where I need to be? Source? Okay, I finally found some Rust files. Handler, inspector, optimism, context. EVM context.rust. Sure. And it looks like we're about to like find this thing. Execution context. because sometimes execution, EVM context, pub struct EVM context, inner precompiles, inner EVM context, inner EVM context. Okay, this is just like impossible to navigate without like actually having it on my computer. So git clone this. And let's just plop this as additionally REVM. Plop that in here. Let's close all this Python. Code values. No need for that. REVM. Decide was in crates. REVM source. REVM, right? That's like the crate, the main crate that it's providing. Sort of the Rust repositories are impossible to navigate. Context. Inner EVM context. Pub use inner. Can I go to definition? No definition found. What? Do I not have like Rust? Inner EVM context. Module inner EVM context. Primitives. Source. Context precompiles. EVM context, EVM context. So like we have a context, we have an EVM context, we have an inner EVM context. Like what the heck? Context database, EVM context. External contexts. Is it that like I need to like import things? What happens if I click on this? EVM.rust. References this 1024 stack limit size. So struct, context, handler, containing both EVM. I wish people who wrote documentation would like realized how like insane they sound when they have like a struct EVM which says that it contains an EVM. I guess it's like EVM context containing both EVM and contains EVM context and its external context is what they mean. EVM context. So a context is like a pair. Why does it have to be so complicated? If it just like contains a pair, why not just like directly? Okay, at least we know navigation is working. Right? So it's like, was it really necessary to create like a separate struct for this like pair here? Is context used anywhere else in this code base? I'm not sure. There's a point when like duplicating code becomes like helpful for understanding things. Default for context. Context. New empty context. Creates the new context. Transact commit. Commits the changes to the database. Okay. Yeah, like I sense that this is transaction in the sense of a database transaction rather than the sense of a Ethereum transaction. Returns EVM builder. It doesn't help that like all the words are overloaded. Return specification that the EVM is instanced with. Transact transaction. Yes. Makes perfect sense. Run the loop. this looks important. A vector with capacity 1025. That's interesting. This is the call stack. Call stack push the first frame. They call it a call stack. Is it really best described that way? Is that what I'm supposed to like get from the stack based? So in Rust, there's all these like traits. We have a trait called host. Makes it hard to know what is ever going on in any particular place. Let me read this like run the loop function. We push a frame onto the call stack. Code is inactive. Let shared memory be a new shared memory. Let a stack frame be the last unwrap. Peek the last stack frame. Okay. We run the loop. Run interpreter. Interpreter equals stack frame frame data mute. Returns a mutable reference to the frame data. Dot interpreter. Wait, sorry. I need to like improve the size of this. Next action, interpreter action. Run shared memory instruction table. Interpreter.run. Let's take a look at this function. Interpreter.run takes a shared memory and instruction table on a host. It runs a self.next action. Mute self. What is the self? Sorry. Self is the interpreter. So it takes the interpreter, gets the interpreter's next action, or it says it sets the interpreter next action to none. It gets the shared memory, whatever that is. What is it shared with? Symmetrical and shared between calls. Use effect for internal representation. A shared memory instance should always be obtained using the new static method to ensure memory safety. Main loop. While self.instruction result equals instruction result continue. Self.step instruction table host. So again, self is the interpreter. Now we are taking a step. Step. We get the opcode from the instruction pointer. In analysis, we are doing padding of bytecode so that we are sure the last byte instruction is stopped, so we are safe to just increment program counter. Self to instruction pointer is unsafe. Self instruction pointer offset count 1. Instruction table opcode is use size self host. Right. So we get the opcode. We index into the instruction table with the opcode. That is then a function, right? This is totally wild, but this is like a function. We're doing functional programming, boys and girls. We operate on the interpreter and the host with this opcode. FN. Instruction table, right, is a list of functions, right? It's a list of functions that sort of update things. Okay. Return result consisting of a result, an output, and a gas. So that's a step. Self.step, it executes a bunch of steps. Sorry, can I go back here? Right, I was stepping through things. So I run until I run out of steps. Take error and break from the loop if there is any. This error is set from interpreter when it's interacting with the host. Take shared memory back. Shared memory is interpreter take memory. Self.handler execution. Okay, exec. What is this? Execution handler. Frame or result. Match next action. Interpreter action. Exec call. Create. Exec.create. EOF create. Exec.eof create. Return something. Return frame. Call stack back frame. Pop the last frame of the stack. Consume it to create a frame result. Context. Frame or result. So if the result returned frame is a call frame, then we call return. If it's a create frame, we do create return, and it's an EOF create, we do an EOF create return. I don't know what those different things are. I don't know why there has to be one for each of them. I just feel like there's so much like here that would be like not necessary to write down if things were much like cleaner. Like we have a list of instructions. B256. So this is the host trait. What is host? Like, host of what? I can tell that this is like the key part of the code that like runs the main loop for the EVM. EVM instance containing both internal, yeah. Right. So this is like this is saying that EVM like implements a particular trait. Is like all these like type classes. Context and handler handles all the logic. It's an ext external contents type ext, go to definition of the type. Yes. Okay, no, it's like an abstract type or something. EVM context, but what is it initialized with actually? What is like the actual, how should I be thinking about what this is? The database interface. I should go to I should see the database interface and see what it has. It's just a trait that has an error type. Okay, it's a trait that has an error type, has a function called basic. Like, you could sort of see how all of this could just be automatically translated into It was like, it would be something that would create a class. The class would have 4 operations in it. Get storage value of address and index. Yeah, it's basically get the storage value of the address. It's basically like a list of addresses, right? This is basically the state. I can think of it that way. And it's like a state in the form of a get account code by hash, get storage value of address and index. I can index into some address's memory. Storage, no, it's called storage for an account. Get a block hash by a block number. And okay, well that's sort of totally different. Get a block hash by block number. What is B256? Result? It's just like a 256 byte string. It's like a hash, basically. The point is that it's always a hash, right? It's just you can get block hashes. Everything is referred to by a hash. Okay, so I'm why can't I, if I just do this. I'll comment all of this out. Class. What happens here? Unexpected token. Okay, well I don't want them to be defs. Def is definitely not the syntax. Database. It's thinking it's a type transformer. Is that how it should be? Trait database. What is a trait? Trait, a common interface for a group of types. A trait is like an interface that data types can implement. Yes. When a type implements a trait, it can be treated abstractly as that trait using generics or trait objects. This is so the analogy is group, right? Group is a type class. It's traits are analogous to type classes, right? Does Rust have type classes? Rust type classes. What is the difference between traits in Rust and type classes in Haskell? Superficially similar, yes. There's some differences. It's not much different, they're still there. Haskell describes functions or values, type classes methods. Just as traits describe OOP methods in the objects they enclose. It deals with these differently, treating them as individual values rather than pinning them to an object as a One thing that Rust could not do for a while is higher order typed traits. Yes, functor and monad. Wonderful. Monads. This means that Rust traits could only describe what's called a concrete type. So it just seems like type classes are strictly more powerful, maybe. Which means, in theory, I should be able to just... It's weird that it, like a class. I mean, I think the point is that it should not be... It should not be this. It should just be like a type, right? Alpha type. So, like, we can say that there's an implementation of the database class of a particular type. Right, object groupoid for a particular object has some property. Sorry, no, I should be able to find group. Group, yes, it takes a single type argument. And this is just like some other stuff, but I think this is correct. Okay, so like I can just start making classes. And of course this like M is total garbage. I don't need that. Right, the point is that I have a whole bunch of functions. Right, sorry, if I look at the source here. Yeah, I mean, is this what I want? Address, go to definition, no type found. Of course, yeah, like, so obviously, yeah, whatever. What is happening here? It's an auto implicit, obviously. I don't want that. Where Rust address? Where are you defined? Go to definition. Alloy primitives. Cargo registry. GitHub.com. Alloy primitives. Is that where I am? Have I gone into a completely different repository? Seems that I have. I guess that's okay though. An address. Pub struct address. Wrap extra bytes. Wrap fixed bytes. Okay, this is some weird thing. It's macro. I feel like we decided that an address is just 20 bytes, right? Yeah, it's just 20 bytes. Maybe I'll just like type address, just def. Sorry, I need to like get myself in the mindset of writing code lean. This is just gonna be 20 byte. What are you complaining about? It's Stuck at solving universe constraint. Okay, like what is the actual byte? Unknown identifier byte. Am I insane? Is it bytes? Bytes? What is the byte? Byte array. What does it consist of? Byte array. Uint 8. Okay, so they only have uint 8s. I guess that makes sense. Yes. Address is 20 bytes. Cool. And now when I mouse over address, it is confident that it's a type. Now I just account info. Like now I need like all of these other types as well. Okay. Account info. So let me like go back. That's address. I feel fine about that. Where's the Rust code that I was at? I was here and I found address. Am I okay? Obviously, context. Where was I? Database. EVM context. Go to definition. I don't know where I was. So I had written this. I had written this database thing. Inner EVM context for a DB. Inner EVM context. Where is this defined? Inner EVM context. Pub struct. It takes in a type DB for database. Implements database. Right. So the way that this would be written. Let me just like try and do this translation as well. Right quick. I can do this DB database class database. So now that I have this, right, I can comment this out and like hopefully it will start structure inner context DB of type satisfying type class database DB where EVM environment contains all the information and environment. So yeah, like plenty of, what I need to do is turn off auto implicits. How do I do that? I would always forget. Turn off auto implicits. Like really the bane of like trying to like make any actual code in this language. How do you spell implicit? Implicit. Just turn, it's not a complete solution. Okay, well, turn off auto implicits. Okay, this is for some other problem, but what I want is to turn off auto implicits. Yes, thank you, Andre Bauer, for complaining. This is the one where he like goes like, this is like a mistake from the 50s, whatever. Lake file. Yeah, more lean art. I think more server options. So I have to like, is the point that I have to like copy and paste these things? Okay, well, sorry, if I go over here, at the top level, there should be a file called lake file, which is this one. Lean lib this, where, okay, package leth, default target lean lib leth, any library configuration options here. Can I just like do this, copy this? Maybe this, like configuration file changed, restart. Go to evm.lean, save. Can I like restart this file? And it's gonna start being mad about address. Yes. Okay. Yes, let's start like rearranging things. Okay, address. And then now it's hooray! It's finally like giving me errors for the values that I have not defined. Okay, execution context we'll define later. EVM database interface is this. This is this. Database. going through one at a time. Database defined here. Go to definition of database. Yes, this. Account info. Result option account info. Result option account info. Wait, just a sec. Did that get translated right? See, it said option account info, but what I really wanted was result. Like if I wanted to make it like exactly analogous. Result. Right, this is just like an error value. Result type error, self.error. The database error type. I go to definition. The database error type. Yes. Does Lean have something like that, which is like result type, result, like they have in Rust? Of course, if you don't spell it right, it won't get it. But estate m.result, lake.result m. I don't think I want something from the lake. Like this, maybe? Result. Result is equivalent to accept. Okay or error, yes. Error, sigma, alpha. Result takes in a type and an error type, and it can either be an okay of the type or an error of the error type. This, what is alpha? Result E sigma alpha is equivalent to accept E, I should be saying epsilon, sorry. Oh God, close. Yeah, it should be the error type. And like conveniently we've defined it here. Maybe it's just a slightly different concept in Lean. Result is equivalent to accept. It has the okay and the error values. But why does it need an alpha? It's because it's part of some monad that is operating on alpha. Yeah. Result. Equivalent to accept. Inductive accept. Accept epsilon alpha is a type which represents either an error of type or an okay value. Okay, I think this is what I'm looking for. Sorry, if I go back, result equivalent, but using a single combined inductive yields more efficient data representation. I'm not exactly, okay, so this is maybe what I'm looking for more. Accept can either be an error or an okay. Yeah. Accept error alpha. So I think what I really wanted here was accept. So like returning to this, that it was supposed to translate correctly. What I wanted was a result, option, account info, or error. But what I will get is an accept error. Error. Option, account info. Okay, this is still unidentified. That's fine. Moving forward. Account info. Go to definition. It's a struct. Copy the struct. Go back here. Above this. Sorry. I'm like what I'm trying to do sort of is like alternating commented Rust with uncommented. Shouldn't it be where? Am I crazy? I feel like it's where. Cool. And it's declaring that I am missing more things. That's totally fine. U256. That's like a uint 256. Does that not exist for Lean? Wait, it's just like a bunch of 64-bit integers mashed together, right? U256 alias. What? It's trying to tell me this is type alias, but I don't really get it. U256 is B256 bits. 256, 4. Why is there a 256 and a 4? I don't get it. What does the 4 mean? Like this is where it's defined, right? Yeah, U256, B256, they're all the same thing. They're all like 256-bit integers, I guess. Just like a UN64 is a 64-bit integer. Yeah. 64-bit integer. Okay, now I'm just like 8. Yeah, like an 8. UN8 is an 8-bit integer. Okay. So this is a 256-bit integer. RUint bits. Is that what this like? Does this what is this parenthesis notation? Is it supposed to like communicate that I have a bits, a bit array of some kind? Okay, I'm not entirely sure. Uint limbs. The ring of numbers modulo 2 to the math number of bits. RUint. Uint const bits, const limbs. Okay, I see. So it's a number of bits. That's fine. Yeah, this is okay. It's just some like internal thing that doesn't affect anything about the actual integer. Do we have like a uint 256? Uint 256. I think the answer is probably no. We do have such a thing for like 64 though, right? So here's like up here is where I'm putting things that are not uint 256 equals bin 4 to uint 64. So that's a uint 256, and both u and b are exactly the same. So def u256 is that, def b256 is, that's not exactly that, uint 256. Sorry, this has capital I. Option bytecode, unidentifier bytecode, cool. So if I go back over here to wherever I was, it's an option bytecode. Diving deeper, ever deeper into the code. Bytecode. State of the bytecode analysis. Pub enum bytecode. Okay, so this is an enum, which means that it should in theory be like inductive, right? So let's copy this. Ethereum object format. I wonder if it will like anticipate that I want to make it inductive. Yes, that's cool. Legacy raw. Like this. Okay, now I just have to figure out what's going on. EOF. Pub struct EOF. So like yet more structs. Legacy raw bytes. Pub struct bytes, pub bytes. Wrapper type around bytes, bytes. What is a bytes? Pub struct bytes. Bytes.bytes. Go to definition. Bytes.bytes. What do we got? Is it like a byte array? Length. Okay, so I think this is like a byte array. Byte array. Array of UNAs. I think this is a byte array. So returning bytes is a byte array. Legacy raw bytes. Bytes is a byte array. So go over in here. Legacy bytes. This is a byte array. Byte array. And it returns a byte code. Byte array. Byte code can also be generated by legacy analyze byte code. Pub struct legacy analyze byte code. Copy. Paste. Structure. Bytes, byte array. See, it learns, you know, bytes becomes byte array here, and it learns that it has to be that. Original bytes length is a U size. Sure, and that sounds fine for that. Jump table is a jump table. Cool. What is a jump table? It's just like, it's just interesting to see like how far down we can dive. Jump table. Pub arc. So this is a reference counter, I know. A bit vec of U8s. A bit vec of U8s. The 8-bit, a bit vec. Bit vec. Is this just a vector? Span description of the live bits. So it's a bit vector. I'm not sure that we have like a bit vector type. Bit vector. Bit vec. Oh, maybe we do actually. Bit vec. But can we like, okay, so bit vec, bit vec, bit vec. A bit vector of the specified width. Yes. Okay, so we have that. So jump map is a bit vector. I think what it's trying to communicate is an 8-bit bit vector, maybe. Size equals 24. Bit store, bit order. Yeah, this is the automatic reference counting type in Rust. Debug for jump table. Bit vec. Bit store, bit order. Capacity. Allocation capacity. Constructor. I don't really know or understand what's going on, but I just want to like, maybe I just want to ignore this for now. A jump table, def, jump table equals a bit vec. Okay, that covers legacy analyze bytecode. Popping back up the stack to bytecode. Bytecode can also be an EOF, Ethereum Object Format. Sounds like it might be complicated. Consists of an EOF header. Right. Good to start copying. It's just like, I understand that like what I'm doing here is not it's not like the right way to code, but I just am like interested in understanding whether how much like translating will the AI do, sort of. as well as like, okay, if we like do this in a more structured way. EOF, header, body, and bytes. So it doesn't know what this is. EOF header is this. Yeah, you could just so easily imagine like something that would like translating this into idiomatic lean, right? It's like all these derives would become, they like, you would use the like typical derive mechanism in lean. We would have like some one of the like at syntaxes that you see in lean. EOF header looks like this. EOF header looks like this. Structure this. Okay, literally everything is cool. Let me just like make sure that I got all of this right. It says that pub types size U16 is this. Code size is a vector of U16s, which is fine. That's array, right? Pub container size is an array of UN16s. EOF data size is UN16. And some code sizes is a U size, which is giving nat4, and this is also a nat. That's totally cool. EOF body, go to definition. This looks something that it, ooh, okay, type section, I don't know if it's going to handle, but yeah, it doesn't know what that is, but everything else it knows. Okay, let's find out what a type section is. Vector of types section. Okay, so it's just a pretty simple struct. I'm beginning to like go insane and lose my place in the actual file that I'm like writing here. But like, comment all of this out. I write struct. Yep. And now it's happy with that. And now EOF body is happy, and now EOF is happy, and now bytecode is happy. Everything is happy all the way back up to the inner EVM context, which I think means that we can like close to the right. That's sort of a fun way of doing things. It's like, yeah, so you could just go through this entire repository file by file, and it wouldn't be too hard. Wouldn't be too hard to just like do this process. You could like automate it a little bit more. Man, let's like, what this is really conferring on me is like, it's not that like this is the easiest way of doing this, but like if only like somebody were a little bit more creative, like someone could like totally make something that would just translate an entire like use LLMs to translate an entire repository into another language. It could be like a, you know, explosion in the number of repositories that are available for new languages. Okay, where was I? The thing that's complaining now is the, okay, database. Database is not complaining. That's cool. We have everything here. EVM context is complaining. Inner EVM context. Database. Inner EVM context database. This is what we this is the thing we had defined here. Inner EVM context database. Right, basically we had gone here. No, wait. What's going on? Click. Right, so this is the file we had. And we copied this. And we had all of these things. And some of them exist and some of them not. database. We obviously needed to copy the database class definition. Now it's complaining about an env. What is an env? An env is a configuration. Like, can I just keep doing this? Env. Okay, so like I have three more things I need to define. Config block tx. Yeah, it's just very close to being like working. That's interesting. They have a kzg.rs. What does kzg have to do with like the EVM? It should be on an entirely separate layer. It should be like an abstract. Like kzg is like a clean abstraction away from the cryptography one. I don't know why that's there. What does this look like? Config environment. Config. See, okay, so what we have here is a whole bunch of this Rust feature which like allows you to turn on and turn off certain values. Config and env. Chain ID of the EVM. KZG settings for point evaluation precompile. Right. Okay, so this it has to do with the precompile. Ah, that makes much more sense. What's happening? The reason there's like this KZG is because of what I was saying before. Like there's this whole concept of pre-compiling certain cryptographic primitives, and obviously they have that for KZG. So we can do like KZG operations if we want. So what have I been like jumping around in? I feel like I should be paying more attention to like the names of the files. REVM creates primitives. REVM creates primitives. REVM creates REVM. Like this is in REVM creates REVM. We also have REVM creates primitives. Bytecode, for example. Yeah, just like go through and totally port everything. Yeah, so close to like working. Like the main barrier to like really going ham with the translation is like, well, so what would I do if I literally wanted to translate this entire Rust repository into Lean? What I think I would want to try to do is create a Lean directory structure that exactly mirrored the Rust directory structure. And then in each, see, this is the tricky part. In each Lean file, I would like copy over the Rust code, comment it out, and then I would try to like just go in and like after every declaration, every like Rust declaration, I would try to like add an analogous Lean declaration. This is like such like mad scientist level. I wonder if I could get my local LLM to do it. Well, I think that's probably much worse at writing code than GitHub Copilot is, though. Yeah. Yeah, seems very possible somehow. It also just seems like very possible to write something that just translates Rust to lean directly. Like every enum becomes an inductive. Every like implementation, every implementation becomes an instance, right? Every implementation becomes an instance. That's like the one thing that I haven't done yet in my like things here. Like the structs become structures, the enums become inductives, the traits become classes, the implementations become and the impulse become, sorry, what is it in lean? It's become instances of type classes, because the traits are type classes, and so you would have an instance of the type class. Yeah, translate Rust code to lean code. I wonder if like, let me look again at the like project. Not this one, not this one, this one. No. This one, and yes. Yeah, this pronunciation guide here, you've just written out the same letters that are in the name. Okay. Aeneas. Okay. Yeah. Verification toolchain relies on a translation of Rust's MIR. So there's a Rust internal intermediate representation language to a pure lambda calculus. Pure lambda calculus. That's not a typed lambda calculus, it's a pure lambda calculus. I sort of want to like do it just to understand what it would look like. Like what would the output code look like? A verification toolchain for Rust programs. Can it handle an entire Rust like structure, like an entire Rust repository? Project, whatever, crate, whatever they're called. Which compiles Rust intended to be used in combination with Karen. Is this another one of his projects? Yes. Oh shoot, I didn't mean to delete that. Yeah, he's got his nice like classical paintings. Intended to be used in combination with Turin. Compiles Rust programs intermediate representation, LLBC. Compiles translation from Rust MIR to LLBC. Okay, well, is the intermediate representation LLBC or is it MIR? MIR seems like it's IR seems like it probably. MIR, Rust, MIR. MIR, Rust compiler internals, LLVM, yes, MIR. Mid-level intermediate representation, yeah, so it's an LLVM. Not low-level, mid-intermediate representation, low-level intermediate LLVM. LLVM-IR, yeah, okay, well. Project structure. Let me just, I just want to like, what is the process for running it? Requires Karen ML library defined in the Karen project. The simplest way is to clone Karen, go to the compiler, and create a symbolic link to the Karen library. If you want to test if the symbolic link is valid. The other question is, were there nested loops? I don't know if there were. If you want to test the symbolic link is valid, there's also a strong possibility that this like markdown file has not been updated. When was this markdown file last updated that I'm reading? README. Where's the README? 3 weeks ago it was updated. So, okay, well. Because like none of these, I feel like I've seen like this like whole list of things before and it wasn't, it's like it's just not changed. So it's like, we plan to address these one by one. Well, it has been quite a while since you have said you plan to address them. And you haven't necessarily done that. So If I go to the README history, actually, can I browse the history? Sorry, history. It's like it has a targeted subset. Is it going, like, if there is a single nested loop, is the whole thing going to say nope, can't do it? We would be interested in having Isabel. Yeah, tutorial for the lean back. Okay, well, wait a minute. This is interesting. Tutorial for the lean backend. So what I want, a tutorial about using lean to verify properties of programs generated by NES. Is this it? Like, is it even possible? Is the problem that this doesn't even try to translate? Like, I would just like to translate the code, please. That you're going to tell me that it's like much harder to do that sort of thing. A tutorial about using lean to verify properties of programs generated by NES. Import base primitives result tutorial. Simple arithmetic. As a first example, let's consider the function below. Def mul2 add 1. There are several things to note. Machine integers. Because Rust programs manipulate machine integers which occupy a fixed size in memory, we model integers using types like U32. The type of integers will take their values between 0 and 2 to the 32 minus 1 inclusive. 1 is simply the constant 1, seen as a U32. You can see a definition or its type by using the print or check commands. It's also possible to jump to definitions. Yes. U32. Is the claim that this was generated by some Rust code? Does this come out of mul2 add 1 is like a Rust code thing? A result? A result. This is lean code that I'm looking at. Yeah, I'm looking at lean code. I see the name result, which is funny because I felt like before I had to put except in. Result. It also doesn't specify an error type. Okay, but it does say okay. Let x1 equals x plus x, let x2 equals x1 plus 1. Mul2 add 1, yeah, okay. Are we still, yeah, we're still actually, we're just, okay, we're in the same tutorial for the same repository that we were in before. We show a desugared version of mul2 add 1 below. We remove the syntactic sugar and inline the definition of bind to make the matches over the results explicit. Yes. Yes. Desugared. We show a desugared version. Right. So this is just like, it's all inside some result monad. Fine. Which is probably the reason why I wasn't understanding what was going on before. Result. Yeah, sure. Are there any other like things that it doesn't include that look like they might be critical? No function pointers, closures, traits. Okay, well this is like a killer, right? This is a deal killer, whatever it's called, deal breaker. It won't work without that. Mul2 add 1 spec, the input, the post condition, the proof. X, yes, like the spec. Okay, so it's like declaring the spec. This is sort of interesting to see how they think. X is a U32. H is 2 times x plus 1 less than U32 max. H is the hypothesis that 2x plus 1 is less than the maximum U32. The post condition is that then it is the case that if I apply mul2 add 1 to x, There exists a y such that that is equal to OKY. The call succeeds, and the output has the expected value, namely y is equal to 2 times x plus 1 as an integer. By proof. Start by rewriting using mul2 add 1. Progress. What is this? Here we use the fact that if x plus x doesn't overflow, then the addition succeeds and returns the value we expect, as given by the theorem. Doing this properly requires a few manipulations. We need to instantiate the theorem, introduce it in the context, destruct it to introduce x1. We automate this with the progress tactic. Progress with th as this, uses theorem th, instantiates it properly by looking at the goal, renames the output to x1, and further decomposes the postcondition. If you look at the goal after the call to progress, you will see that there is a new variable x1 and an assumption stating that x1 equals x plus x. Yes. The call x plus x disappeared from the goal. We progressed by one step. So we progress with x1 and we progress with x2 because those are the two values that we included in the definition, in this let definition here. Then we simp at all. Yes, we are left for goal. And presumably we can just zip everything away. You know, everything becomes much simpler. But it can actually be simplified a bit. In particular, it's tedious to specify progress should use u32.addSpec. In most situations, the theorem is to use as obvious by looking at the function. For this reason, we provide the possibility of registering theorems as a database so that progress can automatically look them up. Recursive functions. Yes, original Rust code pub enum cons t to box clist c t. cnil is just another way of having that. So you take in a t and a clist t. Who knows what the box is, but it's clear that the NDS people are ignoring it. In the clist namespace. Pub function list nth takes a clist and an index. Function accessing the ith element of the list. What is a clist? Cons? So it's like just a, singly linked list. Classic functional list. Cons instead of clist.cons. List.nth of L the clist and I the value. Match L with cons. If I equals 0, return X, else return list nth on the tail. And then you can panic sometimes. Yeah, that obviously you need to panic in that case. What do we get? Divergent. I have literally never seen this lean keyword in my life. Divergent. Huh. List nth t type. It said that they don't have traits. Yeah, that's such a deal breaker. They don't have traits. And in the Rust code, there's all this other random garbage that I hope is not important. You derive things from sometimes. You implement things. DB database. I think there's even the possibility that you can implement things conditional on other things being present, which is totally consistent with. Is there a more advanced implementation? I really like it, by the way, in Rust, how it when you close the parenthesis, it puts it the editor puts it in again, the thing you just closed, so you can see things. That's a very nice feature. Inline, all of this gets inlined. Yeah, just random things that aren't necessarily important. DB database intermittent VM context, DB. We'll ignore the previous error of set. Turns configured EVM spec ID. Berlin hard fork. Access list. Did that happen? Is like, I remember there was talk about this, like access list. Berlin hard fork. Incorporates 4 EIPs. Modular explanation, exponentiation, backwards compatible, new transaction type, bid lower gas costs, opcode transactions. So divergent is obviously, okay, so obviously it returns a result T. So everything in like in a monad here, result monad. T type L C list I AU32, match L with C cons. If I equals this, then okay, else do this. I minus 1. Is that how it, yeah, because it's written as I minus 1 here. List.nth T L I C nil fail error panic. Cool. Conversion to lean standard list type. C list to list. Yes. C nil becomes that. Cons becomes cons. Cool. List nth indeed accesses the ith element of the list. Theorem. List nth spec. Precondition. The index is in bounds. Postcondition. There exists an x such that the nth element of the list is okay, and if I get that in, and it is equal to the thing that I get if I convert L to an actual list, actual honest to God lean list, and I get the index. Yeah, to list by rewrite list nth. Match L, some inductive proof. No, it's just a match proof. And then derive a contradiction. Simp C list to list, scalar tech. Interesting branch. Sure. Recursive functions may not terminate on all inputs. Skip the details of how divergent precisely handles non-termination. All you need to know is that the results type actually has 3 cases. If in a theorem we state and prove that exists, why this? Yeah. So how big is this? I guess the other thing is like, how big is this whole thing? So we have crates. Test EVM. What is that? I feel like this is just EVM, like random stuff. I don't know if this is things that I would have to translate. Port, whatever. Assets. Ooh, they've got a logo. It's a little crab on a chip. Not a very like communicative logo about what this is. Like nothing. There's no invocation of like Ethereum in this logo. I don't know if I like the logo. Whatever. How many files are there in total? 10 or so files here. Not that many. Another like 10, 20. The point is that these are like crates within, right? It's like, it's one GitHub repo, but it defines several crates, which are like modules. Another 10 here. Call it like 40 so far. 40, 50. This one looks like it might be another like 70. Like all told, like, ooh, well, there's a little bit more in here. 90. All told, less than like 100 or 200 files. So maybe possible to like port all of this. Huh. Well, this has been interesting. I might come back to this at some point. But for now, I think I'm gonna turn off. All right. Farewell.